Last time we left off on how to eliminate the parameter or convert to a rectangular equation in our nonlinear section. So we're going to start off here on your notes. It's the middle of page 2. Starting with parametric equation, I want you to look at this right here, and you can see that I've got x equals t plus 4 and y equals t squared. If I want to convert to a rectangular equation, remember, to convert to a rectangular equation, we call that eliminate, eliminate the parameter, which means that we are taking out the letter t. I want to get rid of the letter t. So in order to do that, since rectangular equations are the functions on our calculator, and our calculator is written as y equals, I'm probably going to try and isolate this t so I can plug in over here. So remember, we isolate t, we did this last time, x minus 4 equals t, and now I'm going to plug this in for t and replace it. So I've got y equals x minus 4 all squared. Okay, no letter t anymore. We just converted to rectangular equation. Now take a look at what we have. What shape do we have here? Think about it. Are both terms squared? No, just the x squared. That makes this a parabola. Take a look at what you have for this parabola. You have right 4 right there. Our 4a value is here, okay? Our 4a value is right there. So my focus is actually just very, very, very tiny in front, and my directrix is just very, very, very tiny behind. Oh, my bad. Let's rewrite it as x minus 4 squared equals y. That way we know that this one's supposed to be vertical. I drew that badly. My bad. There is my directrix, and here is my focus above. Here's my focus, and here's my directrix. Well, when you look at that parabola, the latus rectum through the focus is only a total of 1 unit wide. So that's half to the left, half to the right, and this is a very skinny, tall parabola. Don't worry too much about the graph. Just worry about the fact that this is going to be a parabola. We wanted to look at it in this format. It's going to be a parabola that is opening upward, because this is positive, right? The focus, the 4a equals 1, so a is 1/4 above. The focus is 1/4 above our vertex at 4, 0, and our directrix is 1/4 below, okay? All right, let's take a look at the second problem. Once again, I'm probably going to want to get y by itself. So when I take a look at this problem, I've got x minus 2 equals t squared. Now remember, when I take the square root, because I'm trying to get t by itself, that is plus or minus the square root of x minus 2 equals t. Now I'm going to plug in over here, and I'm going to get y equals, okay, plus or minus the square root, kind of getting a shade weird, of x minus 2. All of that is going to be multiplied by 3. Well, I don't even know what shape that is, but I do know that that's a square root function. If you remember square root functions, this is going to be a sideways parabola, right? Well, if it's a sideways parabola, square root function kind of looks like this over here. What happens if I just square the whole problem? Let's just take the whole problem and square it. We're going to get y squared equals 9, and then when you do the square root of the square times x minus 2. Now take a look at what I did. I squared the y, I squared the 3, and then I squared the square root. Now look at it. I've got a horizontal parabola that opens to the right. My a value is 9/4, so that's 2 1/4. My vertex is at 2, 0. So I'm going to come in and I'm going to go 2, 0. My focal point is 2 and 1/4 away. There's my focal point, 2 and 1/4. And through that point, my directrix needs to be, my latus rectum needs to be 9 units long. So that's 1, 2, 3, 4.5 up, 1, 2, 3, 4.5 units down. And you can graph the parabola. You can see that it is a horizontal parabola, so the shape that it is. And the directrix would be 2 1/4 units back. There's my directrix right there at x equals negative 1/4. Okay, 2 1/4 back. All right, next problem. This is different completely. This is cosine and sine. Whenever you see this, you are going to do something completely different. So draw a line right there and say, anytime we see sine and cosine, we're going to start with a new step. The very first thing we're going to do is square both equations. Okay? We're going to square both equations, as long as it's x equals and y equals. We're going to square both of these, and that's going to give us x squared equals 4 times cosine squared. And we're going to square this one, y squared equals 4 times sine squared. Okay, take a look at that. We're going to go back and remember from sine and cosine. This has been a while ago, and I know that, but we're going to go back and remember from sine and cosine, from our trig functions, that sine squared plus cosine squared equals 1. And we're also going to remember that we had an equation where we had x squared plus y squared. So I'm going to now add these two equations together. I'm literally going to add them together. I'm going to add x squared plus y squared on the left equals 4 cosine squared t plus 4 sine squared t on the right. So left side plus left side, right side plus right side. We're still going to leave this x squared plus y squared, we're happy with that, equals. What do these both have in common? A 4. And remember that cosine squared plus sine squared equals 1. So we can actually eliminate that all out. Now I've got x squared plus y squared equals 4. Both terms are squared. They are added. The coefficients are equal. We now have a circle with a radius of 2 and a center at the origin. So I put my center, 2, 2, 2, and 2, and I draw my circle. Okay? All right. On this problem, we're going to do some things a little different. First of all, we need to get cosine of t by itself and sine of t by itself, and that's because they have different coefficients. Notice the cosine here has a 1 and that has a 5. That can't happen. So we're going to move the 3 over. That's going to give us x minus 3 equals cosine of t. And on this one, it's going to be y minus 2, and then I'm going to divide it by 5. Okay? So y minus 2, all divided by 5, equals sine of t. Now that we have that, we can square both equations. Okay? And when we square this one, we can still leave it x minus 3 squared equals cosine of squared t. And this one is going to be y minus 2 all squared over 25 equals sine squared t. Okay. When we look at this, we have to have a common denominator. We add these last two sides together, they're going to need a common denominator. In order to do, I've got x minus 3 all squared plus y minus 2 over 25 all squared. Okay? equals. They don't have a common denominator. We can't actually add them together. But we're okay with leaving it like this right now. Just remember, this is actually over 1. Equals cosine squared t plus sine squared t. We remember from last time that that cancels, and that's just equal to 1. So x minus 3 all squared over 1 plus y minus 2 all squared over 25. Are both terms squared? Yes. Are they subtracted? No. Are the coefficients the same? No. This one has a coefficient of 1. This one has a coefficient of 1/25. We know we have an ellipse. It's wider than it is tall. Its center is at 3, 2. Okay? It has a width of 5 in either direction. 1, 2, 3, 4, 5. That's a vertex. 1, 2, 3, 4, 5. That's a vertex. It has a height of 1 because this is a, oh, I'm so sorry. Forgive me. We had a vertical. This is vertical. And so it had a height of 1, 2, 3, 4, 5, and lower 1, 2, 3, 4, 5, and a width of 1. So there is a close enough graph of my ellipse from the parametric equations. Okay? And that's how you graph it without a graphing calculator using parametrics.